Good morning. So we are back in the mini micro today. I've been thinking about how to handle the dynamic tile generation problem for MicroCraft, which I'm going to rerun that right quick so you can see where we're at. We've actually come a long way since we started this. It loads a lot faster now than it did. But if we go to start game, it's like the level's generating pretty good, but the tiles are rendering too slow. It's because the Java code that I'm copying this from does per pixel rendering. To get good performance on the mini micro, we need to do tile-based rendering, which means that we need to generate those tiles at runtime. There's two ways we could do it. We have these black and white tiles. It's designed to be recolored at runtime and then drawn one pixel at a time. What I would like to do is like go into the grass tile constructor, have it request a number of tiles from the, well, not even the constructor. Whenever you first render it, go to the tile generator, request a tile with this color set with the correct tile index, which is down here. And then it's like every time it re-renders, it can re-pull from that same tile it just cached. That's the way I would like to do it. If we try this for a while and it just does not work, we can create a new tiles image set where we just color all the tiles manually, which would be completely functional. I'm just not ready to do that yet. I still want to try to make this work. I think it'd be pretty cool if I can make it work. And I asked for some recommendations on how to go in that direction. I was given two paths to investigate. One is a code review of a sample in the mini micro, which is what we're going to be looking at today. It's a demo. Is it called Maze? No. Sys demo. It was called Maze. I was in the wrong directory. Excuse me. So if we run this, we can see it generates a maze. I've always loved a good maze generator. Just because it's oh, neat, you can. So if you click on a tile, it toggles whether it's on or off. Click an empty tile, you're in draw mode, and you can just draw tiles anywhere. Click on a full tile, you're now in erase mode, and it will erase everywhere. That's kind of neat. G turns the grid on and off. 1 through 3 changes the thickness. And 4 through 9 changes the color. So let's do some code review. File dot, was it copy? It is copy. File.copy. The old path is sysdemo maze.ms. The new path is just maze.ms. And now you can see we have a copy of the maze program in our game folder. We're only going to be looking at the maze today. And Let's see, how do I want to do this? I'm getting a lot of these little demos here. I think I'm just going to keep pulling from the system pictures for the tile set, but let's go and take a look at that. 2 corner tiles. So there's our tile set. Looks like a fairly complete set of maze tiles to me. Alright, let's make this a little bit bigger. You know, I'm only viewing this one file today. For one file projects, I like staying in the editor. Well, in the built-in editor. I think the biggest reason I keep going back to Visual Studio Code is because of the file list you get on the side. It's easy to swap between all the different files. Okay, maze demo using a wing 2-corner tile set. What is a wing 2-corner tile set? Oh, that's a broken link is what that is. So, clean 2-corner wing tile set from open game art. There's wing and blob tile sets. You know, that looks a lot like what we were just doing. Oh, I created these to bundle with Mini Micro from Joe Strout, who built the Mini Micro. Okay, cool. Does anybody else know what a wing tile set is? One shader toy. That is interesting. Might try getting this to run later. Not sure what I have to do. Oh, it's compiling. Excuse me. Might come back to that. Okay. Oh, here. Google AI has an answer for us. Wing 2-corner tile sets are a type of tile set that uses edges instead of vertices. So, I've actually seen that option in the tiled program. But I guess that part doesn't really matter for today. Let's dig through this code a little bit more. I've actually read a really good book on creating mazes. Let's see if I can find that link right quick. This is the book right here, Mazes for Programmers. That was a lot of fun, digging through that and just implementing all these different maze algorithms. Did that entire book in C, I think. Okay. Yeah, mazesforprogrammers.com. I recommend that one if you want a fun project. Okay, so back to this tile set. Tile set, tile size. So it's basically loading in the tile set, setting up the tile display with all the parameters of this tile set. Trying to remember what extent does. I just cannot hold that one in my head. Extend the display size. Number of rows and columns on your display. Okay. Because that's the width of a display, 960, and 640 is the height in pixels. No scrolling, no overlap. Clear it to nothing. Okay. It's storing the site of each corner. For generating the maze, we'll also have a concept of rooms. A room is one position in the maze surrounded by 0 to 4 walls. Okay. So it treats each cell in the room as a wall. Is that what I'm seeing here? So there's one room with all 4 walls enclosed. You can probably use this to play the dot game. If you never played the dot game, you start with a grid of dots. Kind of like this. And then I want a few more dots. You and another person take turns drawing a line between dots. And the goal is to not close off the rooms. Or not, your goal is to not let the other person close off the rooms. Because as soon as somebody has the ability to close off a room, so say player 1 draws a line there, now player 2 can close the room and gets a point for that room. But what's neat about the dot game is that if you keep playing it with the goal of not closing off any rooms, then what you end up with is something that looks like a maze. It's kind of a neat way to do a random maze generator. Alright, initializing a 2-dimensional list. This is the size of the tile set, or the size of the tile display, and initializes it with zeros. And we have a list of rooms where each room has rows and columns, width and height. And then trying to figure out how this works as we go through it here. The room class is initialized with rows and columns equal to the width of the screen divided by 2 and the height of the screen divided by 2. Now what that means, a single room is basically a 3 by 3 area. Like if you want to make a room, you gotta do 1, 2, 3, 1, 2, 3. So it's 3 by 3. But then it's only considering two of those. It's like it's not considering the north and west sides, just the south and east sides. So as far as the room list is concerned, you only need to consider this bit here, which is 2 by 2. So the width of the display divided by 2 and the height of the display divided by 2. That's where that's coming from. And you can see here, yeah, north and east. I think I said south and east. All right. We have a list of walls. This isn't so much about tile generation as it is about like level generation, but it's still pretty neat because it generates a dynamic map really quickly. And you can use, like, we have this list of rooms. You can use that along with like knowing which of these walls are active in the map to make a little game where you can wander around the maze. r.set, and it creates an array with just this room. I'm not sure what the purpose of this is yet, but it looks like it creates rooms everywhere, activates all of the walls, so everything is turned on. We make one big solid map, and you have rows and columns, but you also have basically the X and Y position here. Rows and columns is not being reset, so I guess each of these instances of a room, we're assuming that it's the smallest size room. Basically that 3 by 3 square I was just talking about. And we'll come back to this function. Set corners from rooms, pick tile, we'll come back to that. Update tiles, which is called immediately, so let's see what this is doing. Update all the tiles on our display from the corners map. Okay, I think this is actually drawing to the tile display. So, drawing to the tiles display, picking a tile, goes back up here. Alright, the tile is based, we look at our corners list to see which corners are active. That was defined up here. Yeah, which corners of the room are active. I think what this is doing, let me clear this out. Need some space to think. Got 1, 2, 3, 4, 5, 6, 7, 8. Let's say that a room has 8 corners. I don't know if this counts as a 9th corner or not. The way this is reading it might. And goes back to the corners 2-dimensional array to get the status of each of those corners. This is only looking at 4 corners. So there you go, 4 corners. Picks which tile to draw based off of that. Now, based on a row and column, it's looking at where we're at. 1 row below. Okay. No, it's looking at a 2 by 2 square. Well, the space just down from it, down and to the left, and only to the left. So that would be like if we're looking at that spot, we also care about that one, and that one. That's how the rendering is happening. Picks those 4 tiles and then goes to the tile set to figure out which of the tiles we're wanting to look at. Like, it uses the value of those 4 corners, converts that into a tile index into this image here. And it's arranged so that the different thicknesses are on the different rows. Alright, skipping remove wall, skipping do 1 step, skipping generate. Oh, so everything up there is for maze generation, everything below is for event handling, drawing with the mouse. If locals equals globals, when you're running a program, like running a file app by itself, like especially if the file doubles as like between a demo program and a library, you'll often see this construct. Python has a similar thing to test to see if the current program is the main program. Current file is the main file. This does mean that you could import this maze file from the demo library as its own library. If you want to import it into your own program, it would be pretty easy to do. Alright, so generate a maze, print instructions, and then we loop. Instructions are pretty straightforward. I'm gonna go over the generate function last. For the main loop, yielding is a polite thing to do. It gives the operating system a time to catch up with itself. And then checking the keyboard. This is the different thicknesses. Toggle grid with a G. 4 through 9 are the colors. Goes back to that apply color function, which we skipped. And then anytime you press a key, if you press the key, it's going to update the tiles. Let's look at these functions. Toggle grid. And, oh, well, that's simpler than I thought. By changing the overlap in your tile set to -1, it insets all the tiles, thereby giving you a grid. Let's look at that. Pressing G. It's not actually drawing a grid, it's retracting the rendering of each tile so that it looks like you have a grid. Potato, potato, I suppose. But that's clever. Apply color. Where was that one? For apply color, we have an array of colors. Throw in the color index. The modulus keeps it from going outside the length. Length is like 0, 1, 2, 3, 4, 5, 6. So color 7 would wrap back around to white. And then we loop over the entire tile display and set the cell tint for each tile. Built-in thing where you can basically tint the tile. It adjusts the color at runtime. And that's a pretty cheap operation. Then update tiles. I'm not even sure this one is strictly necessary after, if you adjust the thickness of the tiles, then you would need to update the tiles, because picking the tile would give you a different result because changing the thickness changes the base index. You can see that down here. Based on the thickness, base index is 16, 0, or 32. So 1, 2, or 3, as you go up in numbers, is like 0 is the top, should be the top row, 1 is the middle row, 3 is the bottom row. Let's redo that tile set again. Yeah, 0 is the middle row, 1 is the top row, 3 is the bottom row. I don't know why the thin one isn't on top, but you know, it works. And then the corner at mouse function is what makes the mouse selection work. What is CS doing? Is that just a global variable? Or is it unused code? I'm not sure it's doing anything. I'm going to leave it, but I don't think it's doing anything. I'm sure it did something at some point. Corner at mouse. So based off of the tile spacing, calculate which tile we're hovering over and return the row and column of that tile. That's a fairly standard operation. Biggest difference is that it's subtracting the tile overlap. I'm guessing that means that if the grid is active, you can't click on a grid cell. Let's try that. Turning on the grid. No? I don't know. I really expected that to somehow be part of it. But it's not. Important thing is the corner at mouse will convert the mouse's X and Y position into a row and column on the display. And that would be a useful function for you to remember if you ever need to be able to select tiles with your mouse. Even if I cannot tell you exactly why, it's using the overlap as part of the calculation. The overlap is going to be either 0 or -1, so it's not going to make a whole lot of difference. I mean, the idea is that you want to divide the X and Y position by the tile width and height, respectively, and floor that into an integer. I'm betting that this would matter more if there's a bigger difference between the cell size and the overlap between tiles. Okay, so while mouse stop button. Interesting that it's in the while loop. Means that I don't think I would do this type of construct if this in most types of games, because it's like if this was an active game, you wouldn't want the whole game to pause while the mouse button is pressed. You'd probably want that to be an if and an end if. Grab the corner at the mouse. You know, I'm not sure these 3 lines are really helping us at all here. I'm curious. I'm going to deactivate these and see if it still works. No? Oh, set M. This variable tells us if we are currently drawing or erasing based off of the value of the current corner. So we check to see if the first one was on, then we'll make sure the value that we're changing the tiles to is the opposite. Like if it was on, we want to make sure we're erasing. If it was empty, we want to make sure we're drawing. And then as long as you're holding on the mouse button, it's going to update the rest of the maze to match that. Alright, so that all makes sense. Going up to generate the maze. How do we generate a random maze here? While walls do one step, set corners from rooms and update tiles. We know what update tiles does. It updates the tile display. Set corners from rooms. All right. Thinking. Okay. So we have two loops. One that looks like it's just initializing. Okay. What this is doing is, let me make sure I'm saying this right. If x is equal to the last column, or y is equal to the last row, this will set it to true. So this is ensuring that there's always going to be connected tiles along the top and right edges. Because you gotta remember, in the Mini Micro, the y-axis is flipped from what you might expect. So make sure that this is on. Ooh, I just saw something interesting. When I draw on the top, it's drawn on the bottom also. You see that? Check the very bottom of the screen and the far left and right. So this maze is wrapped around on itself when it's looking at the corners. So basically, by setting the last row and the last column, it is making sure the entire maze is surrounded by walls. And then set corners from rooms, going through our entire two-dimensional array of rooms. Each room, remember, it only has the north and east walls that it controls. And it sets the corners array to true if that wall is active. Interesting. So each room controls three corners. The one that is just to the north, the one that's just to the east, and the one to the northeast. And it looks like the northeast corner will always be active. So theoretically, if I turn those two off, we should get a room full of dots. And there you go, room full of dots. There's your dot game I was just talking about. You actually could build a little dot game out of this. Have it swap between two colors as you go back and forth between player 1 and player 2. Keep track of a little score somewhere so that you can know who's winning. Alright, back to generate. What is do one step, and why is it saying while walls? Just remember what walls is. Walls is a list that let's see, we create all of our rooms, set it in the rooms array, and then we're pushing walls into the walls list. Room, northeast, and then we shuffle the whole thing. Do one step, like as long as there's something in the walls list, do a step. Pop off the next wall from the walls list. And then, like the walls is a collection of all the walls in the entire maze, along with which room they're associated with. So we're going to get the room index, or the room object, and then either north or east. And then this makes sure we don't erase the edges of the map. And then we grab, like if it's north, then we look to the north of the room. If it's east, we look to the east of the room. And I think neighbor's gonna give us the room, like another room instance. So now we have two rooms. If it's already in the same set as this one, then don't remove the wall. Okay, if room set equals neighbor set, then return. Remove the wall, combine the sets. So we remove the wall connecting the two, and we're making one big list of rooms. Like if two rooms are connected, then they're going to be in that same set. Remove wall, yeah, just set it to false. You know, that's a lot simpler algorithm than I expected. Picks walls at random and like removes the walls. Room set equals neighbor set, then return, like they're already connected, so we don't need to remove any walls. Yeah, that's really interesting. Actually, it is almost like it's playing the dot game with itself. I'm kind of surprised that it's not making any closed loops. No, because if there were any closed areas, they would probably be picked up by the walls array, and it would want to remove a wall somewhere. It wants to join something into the rest of the set. So that's really interesting. Love to see a game made from this demo. But not doing that today. We've talked long enough. And so, close that off there. Interesting foray into dynamic level generation. Next time we talk, we are going to be reviewing this article on the Snake game, which goes a little bit more into generating dynamic tiles at runtime. And I might just go through and implement this whole thing myself, following along with the article. So that should be fun. So yeah, don't click outside the maze because there's not a whole lot of error checking code here. But yeah, I hope to see you next time. Thanks for watching.